Hello students, today we will be doing the error analysis, which is the last chapter of the unit number 1. Before doing the error analysis, I expect each and every students have seen the significant figure video by Pradeep Shetapal. Okay, so let's start what exactly error analysis is. Okay, this error analysis is very important for the experimental physicist. Okay, experiment, those who are performing the experiment. Okay, like an experiment can be a simple experiment like measuring the length of the rod, or it can be as complicated as it is done in nuclear physics, or as it is done in the darkroom experiment. Okay, so what are the errors that can be involved in performing the experiment? The detailed part of it we are not going to do, but we are going to do what we basically need for this time. Okay, see, our basic idea is in every experiment. Okay, in every experiment. Okay, in every experiment, whatever the experiment it may be, in every experiment there will be some error. Okay, this is our idea. There will be some error. Okay, there will be some error. Okay, that error may be due to these errors can be due to the instrument, right? This error can be due to the instrument, because some of the instruments are precise, some of the instruments are not that precise. Some of the error can be due to the human negligence. Okay, human error. So every what to say, whenever an experiment have been done, okay, we assume that our idea or basic idea is there will be some error. Okay, then what to say, we have a idea something called a true value. Okay, true value. Now, how to know the true value of an experiment? Okay, like suppose in order to understand this, let me take an example. Okay, suppose here is a length of a rod. Okay, this is the length of a rod. Okay, then you have done an experiment to measure its length. Okay, then you have measured it let's say you have measured it 3 times. Okay, first time when you measured it was 3.52. okay, next time when you measure it measured, let's say 3.53, let's say centimeter. Okay, you were measuring the length of the rod, and in the first measurement you measured it as 3.52. Now you measured it as 3.53, and the next time when you were measuring it, you measured it as 3.54 centimeter. Okay, all the 3 times, okay, the readings are different at the value of after the decimal on the 100th place, right? Okay, now which is the true value? Okay, because we have an idea that whatever the experiment we do, there will be some error, and that error, it can be due to the instrument, it can be due to the human error, it can be due to the other reason, experiment, what to say, laboratory condition, the physical conditions. Okay, then the true value, what we say, it is the nearest correct value. Okay, actually it is the nearest correct value. Okay, this is the nearest correct value. Then what to say, what is our idea? True value in this case will be what? True value, nearest correct value is mean. Okay, this is we consider the true value. Okay, what is a true value? True value is the mean of the readings. Okay, so what is the mean in this case? 3.52 plus 3.53 plus 3.54 divided by how many times the experiment have been done? 3 times. So what it will be when you do the calculations, this 3.53. So this is the true value. Okay, so any deviation from the true value, so this is considered as a true value. Okay, now any deviation from the true value is the absolute error. Then we have a concept, something called absolute error. Okay, absolute error. Okay, I took the example. Okay, see, my writing is not proper as I'm holding the mobile on my hand, so please, absolute error. Okay, absolute error. Absolute error is the difference, as I have said, it is the deviation from the, from the true value. So in the first case, all right, in the first case, absolute error, how much it is? Okay, this is true value is how much? 3.53 minus 3.52. This is how much? 0.01 centimeter. This is the absolute error for the first reading, right? Fine. In the second case, what is the absolute error? This is the first. Number 2, the second will be what? True value minus the measured value. This will be what? 0, right? And number 3, all right, number 3 is what? True value is how much? 3.53 minus 3.54. Remember, this is also 0.01. Minus will be there. But whenever we are talking about the absolute error, okay, we don't write the minus. All right, because it simply tells about the deviation. Okay, so minus shouldn't be taken. Understood? Then for this experiment, all right, for this experiment, what is the mean absolute error? Mean absolute error. Mean absolute error. So the mean of all the error will be what? In the first case, it is 0.01. In the second case, it's 0. In the third case, it was minus. But as I have said, in the absolute error, we don't take the minus sign. Okay, because it only tells the deviation. Okay, the deviation can be from the correctness. It can be on both the sides, right? So it doesn't mean it doesn't matter the deviation. It only, as our interest is just about the deviation, so we are not going to take the minus sign on it. All right, so 0.01 divided by how many? 3. All right, so how much it will be? 0.02 divided by 3 centimeters. So this is the mean absolute error. Okay, so now we can calculate this one. So this is equal to what, student? 2 into 10 to power minus 2 divided by 3. I can write it, right? Then this is equal to, okay, now 2 divided by 3 we can do it, right? 2 divided by 3, if I do it, then this will be this 6, 18. This will be recurring 6, 7. Okay, so this will be what? 0.667 into 10 to the power minus 3 is the mean absolute error. Means what? In every now the the gist of all this, let me tell to you. See, whenever an experiment is been done, simple experiment or a complicated experiment, in every experiment there will be some error. This is our basic idea. Okay, now how means the error may be due to the instrument, due to the human error, it may be due to the physical conditions. Okay, there are some nomenclature like gross error, systematic error. We are not going to discuss that, is out of our interest. Okay, so there will be an error. Okay, from then we have something called a true value. Then if there is an error, how to know the true value? Then the true value is the mean of all the measurements that have been taken. All right, so true value, we consider that true value is a mean. Okay, then the deviation from the true value is the absolute error. Okay, absolute error, that absolute, when we take the mean, that is also the mean absolute error. Okay, so absolute error, this is, we need to know absolute error. All right, this this one for the particular experiment, this is in general, it talks when it talks of, okay, mean absolute error. All right, then sometimes even we represent the error by means of another. This is let me call this one. See, most of the time we don't use the word mean. Okay, so don't be confused by that. Okay, number 2, another way of representing error is relative error. Okay, relative error. Relative is means what? Comparison, right? Comparison. Comparison with what? Comparison with the true value. Okay, so any measured value, when you are comparing with the true value, it becomes a relative error. Okay, like in this case, the true value is how much? 3.53, right? In this case, what to say? The absolute error, okay? The absolute error is how much? This one, right? So what to say? Mean absolute error, mean absolute error, mean absolute error. When the absolute error is compared with the true value, it becomes the relative error. You need to remember it. In the note I have given, means when the error is compared with the true value, that is the relative error. And when you multiply with the 100, it becomes what? Percentage error. So percentage error we also have. Okay, so there is a percentage error. What it is? It is the mean. My writing is not good. Mean absolute error by true value into 100%. Okay, so what to say? Error is what? It is the measurement, right? So when we are doing with when we are multiplying with the 100, it becomes what? Percentage error. Okay, so in the what to say, in the class note, I have given you one question to solve. All right, okay, so you can solve this thing. Okay, then one more thing, even in the note also, I have given it in terms of the symbol, like true value. Suppose a number of experiments have been taken, and a number of experiments have been done where the measurement are x1, x2, x3, it goes xn. All right, xn. So many experiments have been done of a quantity, and the readings have come and this. Then what it will be the true value? What it will be the true value, student? The true value is the mean value. So what is the true value? x1 plus x2 plus dash 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 plus xn divided by the number of readings. So this is the true value. What name shall I give this to? In the note I have given it as, so x stands for the true value, right? Now absolute error, right? Absolute error, right? Absolute error is what? Deviation from the true value, right? So for one, let me call absolute error, I could write it as delta x1. For the x1, deviation x minus x1. Okay, or you can write x1 minus x. It doesn't make the difference. Okay, all right. Then delta x2, deviation from the true value, right? x2. Then dash 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 delta xn will be what? X minus xn. All right. Then we have mean absolute error. What? Mean absolute error is what? Mean absolute error is the mean value of the absolute errors of the individual readings, right? I hope you are able to understand it by n, right? So let me write it as delta x only, mean absolute error. Okay, then absolute error, this is our importance. Then one more thing is that error can be represented in another form. This is known as a relative error, right? Relative from the true value. What is the true value? Is x, right? And what is the what to say? Delta x, right? Now the same thing we can have it in the form of what to say? The same thing we can have it in the form of percentage, and this is percentage error, right? Percentage error is relative error divided by what? 100%. So when it converts into percent, so error can be represented in form of absolute, in forms of relative, in form of percentage. Okay, next our topic is when an experiment is being done. Okay, So this what are the error, how to represent the error, this thing we have learned it now, right?